Ladies and gentlemen, this is Amateur Repair Time, back with another cool guitar amp repair video for you this evening. Now, if you didn't see our other ones, I've worked on a couple of these on this channel. This is Amateur Repair Time, so we're going to do an amateur repair of this amp. I bought this online. It's an old tube amp, a little cheapo, but it's a tube amp, I guess, from the 50s, and the guy said it blows the fuse when he turns it on. Ooh, that sounds fun to figure out. I couldn't resist. So he packaged it up and shipped it to me, and here it is. So we're going to look in it, see if we can figure out why it's blowing a fuse, and see if we can get it to work. What do you think about that? Instrument inputs. We can get a whole band going. Instrument volume. Tone control. You can turn look, the tone control is the off on. You would expect that on the volume, but you would be wrong. 120 volts, 33 watts, quarter amp, 50 or 60 cycles. Okay, so let me take this off, and I think he's got the tubes in there for us. So that comes off with 2 screws. The gentleman has put the tubes in a little package for me so they don't get messed up. It's a name brand one, but it's a cheapo name brand. I can't remember. It's not a Silvertone. It's like a K or a Vox or something. Let's see what it says. License notice. AT&T. How to order parts for your guitar amplifier. Well, we got a nice little we've got a nice little list of everything for the Barden Company. Is that what it says? As model number 803. Here are the 3 tubes. 36 AM something or another. 60 FX5. Does that say 60? And an 18 GD6. Okay. Let's see if we can test those. There's the 3 jacks there. Very simple little amp. If it's blowing the fuse, though, it might have a bad transformer, so I don't like that. And what fuse is he talking about? I don't see a fuse in it. But we can work around that. Pretty wild. It's a Widowmaker, I think. I don't know. There's output transformer, and what is the T1 here? It's not giving us any voltages. We'll figure it out. Okay, so yeah, that's what we're looking at. So we're going to have to go in the thing before we try to plug it in or anything. So let me get a... maybe we see if we can test the tubes first to see if his problem was he had a really screwed up tube. Well, if it's the tube, though, I'm going to end up messing up my tube tester. All right, well, we'll test the tubes first just for the heck of it. If I can test those, I've never even heard of any of those 3. All right, so the first one is a 13 AM63. I mean, a 36 AM63. 36 AM3. No, 36 AM3C is what mine is. So I've got it all set up. Let's see if she'll do anything. I'm going to go with it's not great. Nothing. I must not have it in the socket very well. There we go. It's actually a very good tube, but that's probably because it's just a rectifier, if I was going to guess. You know, on tube radios, a lot of times you have the 35 rectifiers. That's a 36. I'm just going to guess that's probably what that is. All right, so on to the next one. That one seems all right. All right, so I was wrong again. It's a 36 AM3B. All right, not C. All right, so this one is a 60 FX5. So I've got it hooked up. The heater voltage will only go to 50 on this tester, so it's telling me to set it on 50. We'll see if we get anything. Yeah. So another good tube. You know, this is good that we're testing these because I have yet to see many tubes that I have that test this good on this tester. Most of mine always come up to like 50, 60. Every once in a while you'll get one to 70. So this is good to see that at least there are some, you know, output tubes or whatever that is that do test good on this tester. On to the next one. All right, and the final one, there's only 3 tubes, is an 18 GD6A. So it's voltage, the heater voltage 18, the sensitivity 80, socket 1, test button 1. Yeah, see, that's what I'm more used to seeing on most of my other ones. We'll get something like that. So that one's marginal, but I haven't seen it telling me there's any shorts. So, and you know, it would be hard for the tube to blow the fuse. There's probably a screwed up resistor or the transformer's bad or something in it. So I think all 3 of the tubes are at least usable, although this one is kind of weak. All right, so the tubes seem at least usable, like I said, and they also are inexpensive. I looked them up. They're not that expensive. The 18 GD6 that we were looking at, 18 GD6A, is just a preamp. Okay, so take 2 screws loose and this thing comes out. And I've very carefully set it here where the speaker is still hooked up. The tubes themselves would mount here. And then there's a plate here we got to take off next. Okay, so I took the screws out. I haven't peeked yet. The gentleman I got it from, and you know, even these little cheapos are not super cheap now, so I paid a little bit for it. But the gentleman I got it from said that it had been serviced by a guitar guy, an amp guy. So let's see. We'll look together at the horror. I'm going to guess some kind of burnt up connection on something, because he said as soon as he plugs it in, it's blowing the fuse. So we'll see what we got going on. The guy that he got this from, or the guy that he had work on it, he said serviced it. Now, I understand it's a guitar amp. So a lot of times the guitar amp guys and girls, they want to keep these old caps in them because of the sound of the caps, but I don't know that that's the greatest idea. So obviously the fuse here is blown, so there was a fuse installed in line. New power cord coming in. Neutral running over to one of the pins of what I would assume is the rectifier tube. Hot coming through a fuse. You know, the flaw of this is There's probably your problem right there. That's a bad idea. What's on the back of this thing? Metal. You would probably see it, though, if it had shorted out, maybe. That ain't a good way to do it, folks. I don't know why you would put that fuse up in the air where it can just touch the, you know, the live voltage running through that, touching the plate. Okay? And then at the same time, the plate, oh yeah, the wire just hanging there, right? But you just touched hot to ground through the plate. So that's probably what's going on. Maybe he's been back in it, messing with it, and there's some stuff unhooked. I mean, obviously, that didn't hook there. So we're going to have to look at the schematic and see what the guy was trying to do. See the yellow and the purple wires that he's added? On the video here, it's looking like those are close to touching things. They're not. It's just he's glued the caps to the plate. I don't know what would have been there originally. I guess a can capacitor was mounted. So it's not, we may be able to leave those as they are. I mean, it could have been done a little cleaner, but it's not the end of the world. And they're kind of protected. The plate would go over this part, you know. So that's probably not that big of a deal. Got an old school cap here. Got two ceramics and an old school cap here. I wonder if this came off of something and that's our problem. Like that broke off something. You know, and then fell inside the cabinet, grounded it to here. As soon as you plug it in, you've got the caps. Wham! Okay. Yeah, so we need to look at a schematic and see where this goes. Okay, so I am looking at the small schematic. AC outlet coming in the bottom. The hot runs directly to the rectifier and then goes from there. You know, the rectifier is going to create the B+. The negative is actually what's switched off, and that, you know, that's pretty common. So the negative runs through the switch, right? And then you can see that the negative runs up here and creates the B-, basically. And you can see over here where the jacks are, it's connected to chassis. And so the jacks are connected to chassis, and the input to the preamp is connected to chassis. And then you get, and there is a resistor, R7, which is a 47K resistor. And you get a capacitor, C5, right? And those turn this chassis ground, they isolate it from the B-, which is here. Okay, the capacitors, so the rectifier is creating our B+ voltage up here. This is B-. This is B+, the dropping resistor, plate voltage for the output, the preamp. The plate voltage here is coming from that. Okay, so the reason it looks weird is because of this. This is not this. This is the ground for all three of those caps. So this is B-. This is B plus because it's coming off the rectifier. And then this is plate voltage because it's dropped by the R11. This whole part here is actually isolated from the chassis by this resistor and this cap, right? So, all that to say, that's not how they've got it hooked up. They've got the hot coming in, going in through a fuse, and then running to the on-off switch, and then being switched into the B minus. Which would work because in the wall, you know, you don't really have a hot in the ground, really. You know, you do, but you don't really. So they're defeating their whole purpose of putting a grounded plug on it. They're sending the hot into the switch and then into B minus, and then the neutral is what's going to the rectifier. So this really should be up here, and then everything's wired properly. And this should run through a fuse and then down to there. And the reason that they did it this way is so that whenever you turn off the switch, you're turning off the hot, but the whole set's wired backwards. I guess it doesn't matter, but it kind of does whenever you get to that point where you have the resistor and the capacitor isolating it from the chassis. So I'm going to go do some research to see if that's how most people do it, but I think you'd be better off taking this loose. So you could leave this how it is, take this loose, and then run a line from here to here so that the switch turns off the entire rectifier, right? And then hook the neutral to this that you would remove from here. So the neutral is running down to here. So you could tie the neutral in there. This is the capacitor and the resistor that are isolating the B minus, which is this, from the chassis, which is the pot, and the 3 inputs. All right, let me go see if I can find a better schematic. All right, so this is how people are modding them. Now, you know, this is all safety stuff, so don't do any of this. Don't even mess with these. It ought to be illegal to mess with them, right? So what the people typically are doing, oh, there's 2 things you can do. They're taking out the across the line cap here, because basically that cap and that resistor are, like I was saying, isolating the B minus from chassis ground. Well, the problem that runs into is chassis ground is connected to the guitar cord. The guitar cord is grounded to the pots on the guitar, and the pots on the guitar are grounded to the tailpiece on the guitar, which is holding all of the strings, which you're touching with your fingers, right? Which is fine because it's all grounded. But the problem is if that cap were to short, now you've got the neutral from the wall connected to it. And as you know, in an AC circuit, the neutral has voltage on it. And they're scared to death of that. You run into this all the time on the tube radios. They've basically floated the B minus above the chassis with a resistor and the cap that they are not showing here anymore. It's a 0.04 microfarad cap. So on a tube radio, if you leave it the way it's originally designed, you replace that cap with a safety cap. Because the difference between a safety cap and a regular one is that the safety cap, whenever it fails, it never shorts, it fails open. They're designed to not be able to short. The problem with it shorting is, again, you would have voltage from the wall through that cap, if it were to short, touching your fingers, right? And they call it the Widowmaker, and the guitar players are scared to death of it. And then over here, on this circuit, they have drawn, so basically they've removed that cap so it can't short. If I was going to do it this way, I would replace that with a safety cap that won't short, because you need that cap to keep buzz off of the signal. And then here's what I was talking about. They have the fuse right here. That's not not a good way to do it. So the fuse should be between the load and the heater on the rectifier, which is just a half wave rectifier apparently. So the reason that you're adding that instead of over here is that the set still has power running through it. And if the cap were to fail, the whole chassis would be hot, even with the switch off. So, you know, there are safety considerations here. Me personally, I'm never going to let anybody play my guitar amp. Solamente moi. Right? But so what a lot of the guys are doing is they're adding an isolation transformer here and hooking up the switch on the other side of the isolation transformer. That way the whole chassis is isolated from the voltage in the wall. Oh, you're going to love this. You're going to tell all your friends. Okay, so what I've done temporarily, this is not temporarily. I replaced this one cap. This one I've left for now. I got to look up what the spec of it is. So when I bought this, the guy said he had it. He sent it to a guitar guy. The guy got it working. He played it for a while, and then he turned it on one day, and it blew the fuse. Okay, my theory is because the fuse just touched the chassis. All right. So you saw how the schematic is. This is the 47K resistor that isolates the chassis from the B negative. I'm calling it the B negative, or maybe a better term for it. I put this safety cap in to replace the one that was in there. So this is what was in there. The 0.04 microfarad capacitor. These are always scary looking whenever the disc ones look like they were coming apart. But I don't, you know. You're going to love this. So what I did was I hooked the hot. I just hooked it back up how it was originally. I hooked the hot temporarily. See how I've just got it twisted to the heater of the rectifier, which then loops around as the input to the rectifier to half wave rectify it, right? And then I hooked the neutral to the switch. Neutral to the switch. And so then I hooked this side already had the B minus wires, and so I hooked the B minus of the filter capacitors right there. It's a good tie-in point. They had the hot going here. I don't know where they had this going. It may have been going there too, but it wasn't soldered very well if it was. So then what I did was I put the tubes back in. And now keep in mind there's no fuse in it now. I just put it back how it was originally. And then I, with it unplugged, turned the volume on, turned the power switch on and turned the volume halfway up. And then I plugged it into a circuit protected power strip and turned it on. And it came right up. So, but let me show you, this is the part you're going to love. This is cray-cray. So I'm going to turn it on. I'll turn it up so you can hear some volume. You should hear some hum here somewhere. My tubes are glowing on the other side. Let them warm up a little bit. Can you hear it? That's this one's tone. No, this one's tone, this one's volume. You hear it? So we're up, okay? Now here's the crazy part. AC voltage. $123 volts coming in. which means that it's going through the switch. Oh, I'm trying to do this carefully, obviously. 123 volts. It loops around over to here. Oh, 123 volts. Now here's the fun part. 123 volts on the chassis. However, not really. What's happening, I think, is the meter is picking up the little teeny tiny bit of current that it can get through this resistor and cap setup, right? But if you check it with a meter, that thing's live, but it's not really live. And so I plugged the guitar into it. This one is actually volume, that one's tone. It's just weird. But it's only got a clean tone and just a kind of toned down tone. They say Keith Richards really loved this same guitar amp. I don't know why, but that's why people are afraid of this thing. If you check it with a meter, the voltage is on this, but you can touch it. I'm not scared, right? I don't feel any tingles or anything. But there is live, I'm 6 inches away, people. It just looks like I'm touching it. There is live voltage going through that resistor just a little bit to where a meter can pick it up. So what do you think? Safe or not safe? So people put an isolation transformer on it. The point I was trying to make a minute ago, I don't know if I edited that out. An isolation transformer doesn't make it completely safe. You can still get the hell shocked out of you if it's running through an ISO. It makes it a little bit more safe, right? But just because you've got an ISO on it doesn't mean that you can't get shocked, because you're basically, it's basically making it where you're not grounded anymore to a separate ground. So like if I were to touch something in this room that's grounded, or even be grounded through the floor or something, and the chassis was live, I'd get a shock. So the ISO gets rid of that, but it's still got voltage running through it if you've got the same thing going on. So anyway. All right, I'm checking the amperage, and it's like 0.1 amp. Something like that. I mean, this thing it uses no power. So that's off. You can barely see it. You see a little inrush when you turn it on. So I'm just trying to figure out the fuse. I think a 0.5 amp fuse would be great, because you're getting nowhere near that, you know. So yeah, 0.1. What would that make the wattage on this thing? Like 15 watt or something? So it's like a 10 watt or 15 watt amp, maybe. This is the fuse that was in it. Let's see if we can figure out what they chose to put in it. I can't read it. Maybe I can zoom in. Sometimes when you zoom in, it makes it easier. There we go. And a half. So they used a 1.5. 1.5, and that's a slow blow. You can tell by the thing inside. So it shouldn't ever get anywhere near 1 amp. It does say on the back of it that it's a 35 watt and that it's a 0.275 amp. But according to my amp meter, it never gets over 0.2. But who knows? All right, so that's how I ended up with the fuse holder in there. I've got it shrink wrapped in line with the hot lead. Remember that plate goes over it. I'm going to put a little, we're turned on right now, by the way. I'm going to put a little connector on the end of this and then attach it right here whenever I put that plate back on that goes on it. I left that one cap because I started looking at it, and that's just, all that's going to do is have something to do with the tone. You know, the signal comes in there. So it's between the signal and one of the pins on the preamp. So I don't think that even if that's shorted, it wouldn't cause any trouble. It would just change the tone of the guitar. So, but with the ground line and with the fuse properly put in and with it all covered and everything, I think it's safe, or at least as safe or more safe than it was whenever they built it. So I'm cool with that for my personal use. Now you may want to put a full isolation transformer in it. So that's the little power transformer. It's not really an isolation transformer, but it kind of acts like that for one of the heater voltages if you look at the schematics. And then, of course, that's the output transformer on the speaker. So I'm cool with it like this. Doesn't bother me at all. And that's how I'm going to leave it. So we were able to get her working pretty easily. I honestly think what happened was the fuse just touched the side of the thing. It could be that someone was trying to update it to make it more safe, and you saw how they had the hot to the neutral, which may have worked, because basically you would be doing the same thing if you plugged the wire in backwards. But it looked to me like that metal fuse had just shorted out against the frame of the enclosure, so I don't know why they were doing it like that. But these little things are only like $1. I've got a whole bunch of these that I use at work sometimes. So let me button it all back up and we'll see how it looks after we've got it done. Okay, I got it all put back together. It's pretty ugly, a little beat up. One of these days I might put new covering on it. I don't know what they call that stuff, but you know, I hate to take the original stuff off, even though it's pretty rough. I don't really mind. It's got a little bit of noise in it because I've got it all the way up. We're on 10. It won't go to 11. And then this is interesting to me that the on-off is on the tone. So if you turn it all the way down but not off, I got a guitar here with a little bit hotter pickups. It basically takes all the highs out. And then as you turn it up, you get more highs. Right? And if you keep going with the volume all the way up, it actually gets distorted. So it's got a cool little almost built-in distortion. Just by cranking it all the way up, it'll start overloading a little bit, depending on the guitar you're using. And that's kind of clean. I can adjust the guitar tone knob. can see why somebody would want to record with it, because you can just crank it up and it'll distort, and you can get several different styles out of it, you know. So if you, I don't know how to play, but if you know how to play, you could really make it sound pretty good. All right, folks, so I think it's pretty cool. I like it. Neat little amp. Consider getting one if you're not afraid of it. We'll see you on the next video. By the way, if you want to see another amp repair video that we did, check out the one there on the left of your screen. We'll see you on the next video. I hope you enjoyed it.